So we're in section 9.2. We're going to graph today y equals ax squared plus bx plus c. So I just want to recap really quickly what we've, kind of the main points that we've talked about the last couple of days. If a is positive, so if a is greater than 0, our parabola opens up. And if a is less than 0, our parabola opens down. So that's how we tell if our parabola opens up or down, is whether this number in front of the x squared is positive or negative. We also said that if a is large, if a is a big number, our parabola is stretched up. And if a is a fraction, our parabola is compressed. So I'm going to say a gives a vertical stretch or compression. So if a is a big number, our parabola gets stretched up, and if a is a small fraction, our parabola gets scrunched down. And we also said that c moves the parabola up or down. So wherever our vertex is, c is going to move it up or down from where it would be if there was no c. And today we're going to talk about what b does to our graph. We guessed yesterday that b might move the graph side to side. That is the case. So we're going to graph these quadratic functions when we have a bx term and figure out how b changes our graph. So for this quadratic function, y equals ax squared plus bx plus c, the x-coordinate of the vertex is x equals negative b over 2a. So that's our first important piece of information today. To find the x-coordinate of the vertex, we figure out what a, b, and c are here, and we do negative b over 2a. That gives us the x-coordinate of the vertex. We also know that our axis of symmetry goes through the vertex. So this tells us also where the axis of symmetry is. So the axis of symmetry goes through the vertex. So this is going to tell us where the axis of symmetry is on our graph. Negative b over 2a. Well, we also need to know where the y-coordinate of the vertex is. So we can plot that point. So what we do is we plug negative b over 2a in y equals ax squared plus bx plus c to find the y-coordinate of the vertex. So plugging negative b over 2a in gives us the y-coordinate of the vertex. So then we can plot that point for the vertex. And we know that our axis of symmetry goes through the vertex. We'll be able to tell if our parabola opens up or down by whether a is positive or negative. And then all we need is another point to plot, and then we can use the symmetry of our graph over the axis of symmetry to plot another point. So the third thing we're going to do is plug in x equals 0 to find the y-intercept. And remember, the y-intercept is where it crosses the y-axis. Well, if I look up here, if I plug in x equals 0 here, I'll write that down here. Y equals a times 0 squared plus b times 0 plus c. Well, this is 0 and this is 0. We get y equals c is the y-intercept. So there's a point on my graph. We know the vertex, we know the y-intercept, and then we can use symmetry to plot another point. So that's going to be our fourth step when we graph these things. So once we know one point that's on the parabola, we can just go to the other side of the axis of symmetry and plot another point, and then we know how wide our parabola is. So our first step in graphing is we're going to use negative b over 2a to find the x-coordinate of the vertex. Our second step is going to be plug in negative b over 2a into our quadratic function to find the y-coordinate of the vertex. We'll find the y-intercept. Y equals c is the y-intercept. And then our fourth step is to use symmetry to plot another point. So those are our four steps for graphing y equals ax squared plus bx plus c. So let's look at an example. Any questions so far?
What's the first step?
First step, negative b over 2a for my x coordinate of the vertex. All right, so let's graph. Y equals x squared minus 6x plus 2. Now, first thing we probably should do is say, well, there's A, there's B, and there's C. So A is 1, B is negative 6, C is 2. So negative b over 2a is negative 6 over 2 times 1. Well, that's positive 6 over 2, which is 3. So this is the x-coordinate of the vertex. So the vertex, the x-coordinate of the vertex is 3. So that's my first step. My second step, I'm going to plug this number into this function to get the y-coordinate. Y equals 3 squared minus 6 times 3 plus 2. Well, that's 9 minus 18 plus 2. 9 minus 18 plus 2, so 11 minus 18 is negative 7. That's the y-coordinate. of the vertex. So I know my vertex is at the point 3, -7. My third step is to say y equals 2 is the y-intercept. C is 2. Well, now I can start to make a graph. So let me put my axes over here. I'm going to do my axes by hand here. So 1, 2, 3. The vertex is at 3, -7. So over 3 and down 7. So I'm going to get a point down here. I'll do my graph in blue. 3, -7. About here. The y-intercept is y equals 2. So up here at y equals 2. And I'm going to make this go over. So, and I know that my axis of symmetry goes through the vertex like so. So what I'm going to do is plot another point. I'm 1, 2, 3 units from the axis of symmetry. I'm going to go over 1, 2, 3 units on the other side to get another point, because I know my parabola is symmetrical about the axis of symmetry. So this point, I go over 1, 2, 3, and I'm going to go over 1, 2, 3 this way. And my graph would look like that. And I kind of missed the point there, but I'll just make that point bigger. There we go. And there's a decent graph of that function. And this point would be 3, -7. And this point is 0, 2. And this point is 6, 2. And I'll say this is the point that I came up with here is step 4. So I did -b over 2a to find the x-coordinate of my vertex. I plug that in to my function to get the y-coordinate of the vertex. I found the y-intercept by saying, well, y equals 2 is the intercept, and then I plotted another point using symmetry over my axis of symmetry for my parabola. If this problem asks us to find the domain and the range, the domain, unless the problem has to do with, I don't know, dropping a ball, dropping something off a cliff, some kind of physical problem where we're starting at time equals 0, something like that. The domain of a quadratic function is all real numbers. If the problem is describing some physical thing, then the domain might be time greater than 0, or time between 0 and 10, or something like that, depending on how the problem is described. The range for this quadratic function. Well, what's the smallest y value that we have here on the graph? Yeah? -7. The smallest y value for this one is at the vertex. And the graph can keep going up and up and up and up. So the range is y greater than or equal to 7. And we could say 7 to infinity if we wanted. questions there? Okay, let's look at a slightly different kind of problem. So we're going to kick a soccer ball. It gets kicked up into the air. And we're told that h, the height, equals negative 16 t squared plus 64 t plus 2 gives the height after t seconds. And notice we have this negative 16 t squared again, like on the problems we talked about yesterday. It's because the gravity near the surface of the Earth is constant. That negative 16 describes that. We have several questions here. What is the maximum height? When will it get there? So that means how long does it take to reach the maximum height? And what is the range of this function? Well, I'm going to draw a little picture to help us visualize this. We know that this is a parabola that opens down because of this negative. So we know it looks like this, something like that. If we're looking for the maximum height on this parabola, where are we going to find it? Isn't it up here? What point is that for our parabola? What special name did we give that point? Anyone? Yeah? The vertex. The maximum height, if this is talking about a quadratic function, it's asking us where is the vertex. And because we're talking about the height, if this were a graph, my axes, this would be, the y-axis would be height, and the x-axis would be time. So the first part of the question is asking us, what is the y-coordinate of the vertex? That's where we find the maximum. When will it get there? That's asking us t at the vertex. So let's find the vertex. We don't even need to sketch a graph now because we know how to find the vertex. The vertex, negative b over 2a, gives us the x-coordinate of the vertex. In this case, that's going to be t. Negative b over 2a is negative 64 over 2 times negative 16, which is negative 64 over negative 32, which is 2. This is the time that it takes to get to the vertex. That's saying this is t equals 2. So that is the answer to question number 2. It's going to take us 2 seconds to get to the vertex. The maximum height is the y value at the vertex, or the h value. So I'm going to plug this in. H equals, at the vertex, h equals negative 16 times 2 squared plus 64 times 2 plus 2. And I plug this into my calculator, and I get 66 feet. So that is the answer to the first question. How high does the ball go? 66 feet. So this point up here at the vertex of the parabola would be 2, 66. Takes 2 seconds to get there, and it goes 66 feet in the air. And then for the third part of the question, what is the range? Well, what's the highest that this soccer ball goes in the air? 66 feet, right? How high is it down here? 0. When it's on the ground, the height is 0. So the range is 0 to 66 feet. Yes. Now, if the problem asks us when does it hit the ground, we could plot some points on our graph and figure out what the time is over here when the height is 0, like we did yesterday. All right, questions on that example? Okay, let's do one more graph just to have a little extra practice. We want a graph y equals negative 3x squared minus 6x plus 2. Well, right away, this is A, B, and C. We know that A is negative, so we know this is going to open down. So our first step, we're going to do negative b over 2a. Negative b over 2a is negative 6 over 2 times negative 3. Well, that's 6 over 2 times negative 3 is negative 6. So that's negative 1. This gives me the x-coordinate of the vertex. My second step is to plug negative 1 into this function to figure out y. That gives me the y-coordinate of the vertex. So y equals negative 3 times negative 1 squared minus 6 times negative 1 plus 2. Well, negative 1 squared is positive 1. Positive 1 times negative 3 is negative 3. Negative 6 times negative 1 is positive 6 plus 2. Well, 6 minus 3 is 3 plus 2 is 5. And that gives me the y-coordinate of the vertex. So my vertex is at negative 1, 5. My third step, we find the y-intercept. Y equals 2 is the y-intercept. So now I can make my graph, because I need my graph to get my other point on the other side of the axis of symmetry. All right, so my vertex is at negative 1, comma 5. 1, 2, 3, 4, 5. So up here. My y-intercept is y equals 2. So I have a y-intercept there. I know my axis of symmetry goes through the vertex, like so. Well, I'm one space to the right of the axis of symmetry here. So I'm going to go over one space to the left and plot a point over here. And my graph is going to open down, like so. And there would be a reasonable graph of that parabola. And this point is what I did for step 4, is I found this point. All right, questions? Okay. Homework is section 9.2. We're on page 556. Now I think these in the 20 through 26 even, I think most of these are not sketching graphs. I know the numbers in 20 through 26 even are sketching graphs. So most of them you're finding the vertex, finding the axis of symmetry. But I know for sure these are the ones where you're graphing.